Okay, hello guys, I'm Egid. So I'm just going to introduce the first topic for today in mathematics. So we can just start for the given unity in mathematics is for level 3 in Tvet for Rwanda. And as you see here, we have the introduction to derivative. Firstly, we have to know what is derivative. And first, you can just talk about with some numerical function. For instance, if you have fx, and this fx can be defined as any function which is dealing with a known variable of x. For example, if you have a 4x square plus 1. As you see here, this function can just contain the unknown variable x by writing to the this variable which is found in the bracket. And as you see also, yeah, our function can just be containing the exponent which is equal to. That is why you can just call it the quadratic equation. Then, by referring to this derivative, we can just have some difference operator. Those operator, they can just be taken as the operator of differentiation. So this operator of differentiation can be written in different form. Here you can just have, for example, by referring to this function, you can just have f of x derivative, or it can just be written as f of x does, or you can just write it as the y does, where this y can be taken as the function of f of x. Also, it can just be taken as the derivative of this y with respect to a known variable which is x that you have. Also, you can just be written as dfx over dx. So these ones, they can just be taken as the operator of differentiation. So by referring to the example that you have here as the f of x, you will see that you can just make the derivative by using different method. So the first one here, you see, we can just have derivative by using property, by using properties. Or also you can just have the derivative by using the definition. So for today, we have to talk about on the first way we can just use when you are just making the derivative. So the first technique here is the derivative by using definition. So for this case here, if we talk about the derivative of using definition, it indicates that you can just use the formula, where this formula can be written as the limit of height tend to 0 of fx plus h minus fx over h. So about this formula that we have, it will be easy if we just know about or the operator on the limit. So it will be easy, and you can just use this content here in order to evaluate or to operate the derivative by using definition. And if it is possible, we shall talk about it on the limit in a full manner. So firstly, let us use this formula in making the derivative by using definition by referring to our example there above, which is fx, which will be equal to 4x squared plus 1. So by taking this example, you see, you can just use this formula in order to derive our function. So firstly, we have to write the formula the function that we have here by referring to the formula. So we can just have this fx in order to talk about the derivative for this function fx. Firstly, we can just write as fx derivative or fx des, which will be equal to the limit of height tends to 0. Donc we can just found the fx plus h. So this fx plus h, you see that here we have the unknown variable, which will be taken as x, as we have seen for the first point, and then you can just add some constant. This constant, which is h here, will be taken as the value of h, which will be equal to 0. And this x can be related to the function fx. Then, as you see, here we have the limit of h tending to 0. We are going to find the function fx plus h. So, we can just take the value of x plus h and replace where x is in our function. So, for finding fx plus h, you see, we can just have 4 and replace where x is the x plus h. So, we have x plus h square, then plus 1. Then this value here can be taken as fx plus h, then negative here fx, and we are given this function fx. So this fx will be equal to 4x square plus 1, so over h. And as you see, you can demonstrate this function that you have by relating to the definition. You see, we can just get the limit of height tend to 0. So we have to expand this by using some identity, and we know that if you have a plus b square, it will be equal to a square plus 2ab plus b square. So we have to refer to this identity, and then you can just demonstrate our equation here. So you can just have 4 times x square plus 2xh plus h square, then plus 1 negative. So this negative here, you see, we can just multiply for each variable here in parentheses. So negative times positive will be negative, and then negative 4x square. Negative times positive will be negative. So you can just get the value of negative 1 over h. So here we can just have fx derivative, which is equal to the limit of h tend to 0, 4x square, then plus 8xh plus 4h square, then plus 1 negative 4x square negative 1 over h. And as you see, for our equation here, there are some variable that you can just cancel due to the sign. So this is 4x square, which will be cancelled with negative 4x square. And this, as you see here, also plus 1 must be simplified with this negative 1. And it will remain the limit of height tend to 0 of 8xh plus 4h square over h. So by referring to this, okay, let us come back. By referring to the remaining stuff that we have here, you see, we can just replace our variable h, which is equal to 0, or where the h is, and you remain the 8x, and then this x can be replaced by the value of 0, then plus 4 times 0 over 0. So as you see, here we have this 0 times this variable 8x, then plus 4. So we get here 0 over 0. And as you see, and as you know, this 0 over 0 can be taken as indeterminate form. So we can just remove this indeterminate form by referring to the technique that we have here. We can just use, for instance, rationalizing method, also you can just use the factorizing method in eliminating some determinant form. Also you can just use trigonometric transformation, and also you can just use the hospital rule. So now we can just use one of the technique that we have above here by referring to the type of function that we have here. This is rational function. It will be better if we are just using the factorization method. So here we can just get the limit of height tend to 0 of 80xh plus 4h over h. So as you see, here we can just take out the h, and it will remain 80x plus 4 over h. So the h will be cancelled, and then it will remain 80x plus 4. So the limit of h tend to 0, it will be equal to 80x plus 4. Then we can just have this kind of equation by referring to the properties of the limit here. The first property, which says that if you just have the limit of a given variable to the constant, so you can just get the answer which will be equal to that constant. And here you have for 80x then plus 4. So this will be taken as the final solution of f(x) derivative, which will be equal to 80x plus 4. So this technique that we use here is the first technique of solving or just evaluating a given function by using definition. So thank you. See you next time.